Okay, Assalamualaikum and good evening everyone. Okay, so let me explain the solution for question Aura week 6 chapter 5. So the question is, okay, let's look at the question. Okay, we have an object of mass 2.5 kilogram. Okay, this is the mass. It's placed 25 cm directly above the top. So we have height here, assuming this is the point of reference, above the top end of the vertical spring as shown in figure 1. The spring constant is K 2000 Newton per meter. Okay, calculate the speed. So the question asks us to find the speed of the object just before striking the spring. So basically we want to find the speed at this position. Okay, so first you have to be clear that in this case we are using conservation of energy. Conservation of energy. Total energy initial is equal to total energy final. So the total energy of this system is constant at any position. Okay, so the position that we are going to focus more is on this case is, okay, the first position, second. So let us label the position. Okay, the label position. Alright, so number 1, position 2, position 3. Position 3 is when this block, okay, this block is at certain height, strikes this spring, and then this spring will be compressed. Okay, meaning, so we are talking about the conservation of energy, meaning at position 1 we are having summation of E1, position 2 we are having this summation of E2, and position 3 is summation of E3. So position 3 is when your spring is being compressed. Okay, so bila compress, it must be the compression lah at this case. Alright, so question wants us to find the speed. Okay, the speed. So speed at this position, position number 2. So now we are just comparing two positions, that is position 1 and 2. So writing the equation. So now we are solving question number 1. Okay, we have to clearly state that E1 equal to summation of E2. Okay, so just write down the equation, the energy we have. So at position, the first position, we only have gravitational potential energy, and at the second position we only have kinetic energy. Okay, so at this second position there is no compression yet, so they'll be having only kinetic energy. Alright, so now we substitute the value. So we have mgh equal to half mv squared. Okay, you can see here we have we have m both right and left, so we can cancel out. So now we want to get the v. So v is equal to 2g over h. Am I right? Sorry, 2gh square root. Okay, now you substitute the value. So you will have 9.81. The height. Okay, please remember, class, remember we need to use SI unit. Okay, so we have to write down 25 times 10 to minus 2. Okay, so the answer that you're supposed to get is 2.21 meter per second. Okay. Alright, now the second question, determine the maximum compression. Okay, so maximum compression, of course, again we're applying the principle of kinetic energy. Sorry, the principle of conservation of energy. So this time, okay, we are comparing position 1 and 3. Okay, 1 and 3. Okay, or actually you have the other option. Okay, you have the other option. You can also use, you can also compare summation of E at position 2 and also position 3, because you have got the velocity at the position 2, right? So it's up to you which equation you prefer to use, so as long as you can solve the problem. So I prefer this one because we have those equation. Okay, so we have mgh, before that we have to know what type of energy we have. So at position 1 we have UG, and at position 2 we have US, elastic potential energy. So the equation is mgh again equal to half kx squared. Okay, so substituting all the values, okay, the mass is 2.5, 9.81, height is 25 minus 2, half, k is given 2000, right? And x is the one that we want to find out. So x is equal to, okay, you do the calculation and finally you'll get 0.091 meter. So this is the answer. So please have a check with your answer. Okay, if your answer is wrong, please make correction. Alright. Okay. Now we move to the second question. Okay, now we move to number 2. So for this question, we have no diagram, meaning you need to draw the condition. So a 600 lift starts from rest. Okay, we have a lift. Okay, so starts from rest means it's u equal to 0. Move upward with, this is the mass, for 3 seconds, this is the time, with constant acceleration until it reaches a final speed of, so this is the final velocity. Okay, so in this case you have to understand the condition of a lift. So basically it has the force of tension, okay, and also weight. Okay, the weight of the lift. It's not weight of the passenger, but it's the weight of the lift, right? Okay, and this lift is moving upward. So remember chapter 4, when we use this kind of equation, we compare, right? We are using summation of Fy is equal to ma. Okay, so in this case, question asks us to find the force exerted by the lift motor. So this is actually, we need to find tension. So based on this diagram, we can come up with an equation that is T minus W equal to ma. So tension is equal to ma plus weight. So you can directly convert weight into mg, and then you do the calculation. So tension here is the force exerted by the lift motor. Okay, so the mass is 600. Okay, and the acceleration here is, we don't have the value of acceleration, right? But you can actually find it from the equation v minus u over t, okay, plus mg. Okay, one more time, we do the substitution. So 600, the velocity is 1.55 minus 0, time given is 3, plus, okay, again we have mass 600, 9.81. So you finally will get T is 6196 Newton. Okay. Okay, now we go to the second question. So question asks us to find the instantaneous power of the motor if the T is 3 seconds. So it's the same period lah for the previous case. So for the solution of the second question, okay, we just use power is equal to FV. Okay, that is equal to, okay, so P equal to FV, so F is tension, V is V final velocity, substituting the values 6196, V is 1.55, and finally you have your power is 3.8 watt. Okay, so that's the solution for Aura Chapter 5 second version.